Hey everybody, it's Mr. Carr again. Today we're covering the last lesson of Unit 4, 4C Day 2. We're writing equations of applications, okay? So one more time, we're gonna go through some application stuff and we're kind of tying it all back to what we talked about before. Again, analyzing that rate of change with context. What's an initial value, things like that. So here's our example. Cab company charges $3 boarding rate. There's a key word there, right? Rate. In addition to its meter, which is $2 for every mile driven. Oh, no, I'm sorry. That rate's not gonna help me there. $2 for every mile. Okay. So I could write that as $2 per mile. Use Y to represent the total cost, X to represent the number of miles driven. I did it again. Some slight delay here. There we go. Okay. Sorry about that. So I want to highlight the fact that it's $2 for every mile. That's a rate, okay? $2 every mile, that's a rate of change. Y is going to be the total cost. X is going to represent the number of miles driven. So write an equation that represents the scenario. Again, we need slope and a y-intercept. So in this scenario, $3 to board. That means you get in the cab, you owe the cab driver $3. That's my initial value. That's that context there. The change is for every mile, we add another $2. So we're increasing by $2 for every mile. So that's my rate. So I plug it into what slope intercept form. I'm going to do 2x plus 3. Okay. Graph the equation. We'll add labels to the axis. So again, we already know X is the number of miles. So we got number of miles. Okay, Y is going to be the total cost in dollars. Okay, so I've labeled my axes. We're going to graph it. Let's see, we got 0, 3. So let's go with, we'll put 0, 0 here. And I'll just go 1, 2, 3, 4, 5. Okay, we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's good. Let's do this. We're going to count every 2. I don't like that. Yeah, we'll just stick with this. We'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It doesn't have to be perfect. We'll get a pattern off of this. That's the only important part. All right. So we're going to graph the equation now. We're crossing at 0, 3. Okay. After 1 mile, we're adding $2. So at 1 mile, we're going to be up to 5. Then we're adding another $2 and another $2. And that's it. I'm off the chart here. Okay. But that's going to represent our fare that we have to pay. Okay. How much does it cost to ride in the cab for 1 minute? What? That doesn't make sense. We're going to call it mile. That's terrible. Okay, for 1 mile. How much does it cost to ride in the cab for 1 mile? All right, so if I look at the graph, I can find that, but I can also just do this. Remember, 1 mile is x equals 1. So I can do y equals 2 times 1 plus 3. So y equals 2 plus 3 gives me 5. So it cost $5. What does the slope of the line represent? Kind of already talked about that. That is the $2 per mile. Okay, so it's changing. If I kind of put in a sentence, okay, the cost changes $2 for every mile. Okay, all right, 3, 9. What does this point represent? So I do have it up on here. Okay, after 3 miles, the cost is $9. There we go. And that's it. So the biggest thing we add on to from our previous application type is we should be able to identify how to write that equation. Remember, it's made up of slope and y-intercept. Okay. The y-intercept is also that initial value. So in this case, 3, because that's how much it costs to board. Okay. The rate of change is the $2 for every mile driven. Remember, rate of change. One thing changes, and then that's two things being compared are changing, like in comparison to each other. Okay, so that's how we get that $2 per mile. Okay. And that's it. So we'll do some more problems with that in class, but otherwise that is it for this one. It's a short one today. All right. Feel free to try that you try now problem out. That's it. Take care.